Okay, today we're going to be getting into the inspection of high pressure CO2 systems, some of the hazards you may run into while doing so, and just some general items to be looking out for. So obviously, on any vessel we go out on, safety is our #1 concern at all times. To start, obviously you want to be wearing all your standard PPE items that you'd be wearing on any other inspection, to include your 4-gas analyzer. Particularly with CO2 systems in and of itself, there's plenty of hazards that can come along with that. One in particular, prior to entering the space, you want to make sure that there's proper ventilation and that it's been running. On this vessel in particular, we have open airway. There's been ventilation the entire time prior to us entering. So the oxygen and the CO2 and everything in the room is taken care of, but not a one-size-fits-all system. On the larger vessels, we'll have entire rooms filled with these bottles. So that ventilation is obviously going to be a key concern, but obviously just stay diligent, look out for each other, and should there be any concerns that you may have, exit the space, investigate, and then go from there. Okay, so just as any other piece of equipment you'll find on board a lot of these vessels, there's servicing requirements, installation requirements, just a myriad of things that go into making sure everything is installed properly, it's being maintained properly, and that it operates properly. The same going for the fixed CO2 system. You're going to have a third party come out annually and verify whether it needs to be installed, it's being installed properly. If it's up for maintenance, it's being maintained properly. It's not something the Coast Guard is going to be doing themselves. More so our role in that is to come out and make sure that those requirements are being fulfilled, and that they're doing their job and properly maintaining and ensuring that their equipment is always in proper working order. Now we're going to be talking about the Odorizing Unit, or the odorizer assembly itself installed on the unit. This system itself does not apply. This is an older vessel, smaller system, but we will be able to show you what that looks like on the system itself at a later point. For the inspection of that unit, it's just another safety mechanism installed to enable our senses to be able to pick up when this system is being discharged. It will emit a wintergreen type of smell into the system, so that your nose can pick up that, like I said, the system's actually being discharged. As far as the actual inspection of that portion of it, we just want to make sure that it's in serviceable condition, that it has not been discharged. We can pop that out, take a look inside. You just get a general idea that it's ready to operate if it needs to be called upon. Next, we're going to be getting into just a general breeze through of ensuring that these bottles are actually installed correctly, and that they're mounted right, and that they'd be ready for transit. Obviously, these vessels are going to be taking seas, shifting around, so you want to make sure that these are secured. They're very heavy, so they could obviously create hazards for falling on people, creating damage to the units themselves, or inherently just discharging the system by accident. So we'll take a quick look. Obviously just the mounting itself, move the bottles around, make sure that they're not going to be going anywhere. Any major corrosion issues with the mounting hardware itself, that something might break free. Obviously generally pretty easy self-explanatory portion of the inspection. We just wanted to make sure that the system is properly mounted and ready for sea. So now that we've verified the mounting hardware is sufficient and the bottles are installed properly, we can get into the material condition of the bottles themselves, as well as the system components. Starting with the hoses and the connections, we can just kind of visually check for any cracking, major corrosion, anything that would cause concern. General condition of the bottles themselves, the actuation points, making sure nothing's painted over or seized in place. Again, any major corrosion throughout. And if all looks sufficient, we can go ahead and move on. If there's any other questions, you can kind of expand the exam, ask some questions, but at this point, it's just a general checking of the components themselves. Then you can move on from there. So next step is going to be verifying that the piping coming from the system itself, as well as the discharge nozzles, are in good serviceable condition, free of any major corrosion, any holes in the piping, and just ensuring that the nozzles in which the CO2 will be discharged are in proper locations, and that the system's actually going to be able to do its job. In this case, we're in the generator room. We have 2 generator units in here. Both nozzles are properly positioned just above them. So in the event of a fire, the system should be able to do its job properly. So while the CO2 system does a phenomenal job in suppressing fires, of course, it does create a lot of hazards to personnel. So with that, there will need to be warning signs posted conspicuously throughout the spaces in which CO2 will be introduced, as well as the CO2 room itself. For example, here, the sign states, "When alarm sounds, vacate at once, carbon dioxide is being released." Like I said, you'll see those conspicuously all throughout the affected locations. So your job is just to make sure that they are installed, they're in proper locations, and that they're legible and easily understood. Next, we're going to be checking to verify that the operating instructions are posted, easily legible and easy to understand. Should be very simple, clear instructions on how to operate this system. And the only thing, in addition, we're going to be checking is to make sure that these are posted at all stations throughout the vessel in which the system can be manually operated. In this case, we're in the CO2 room itself. Like I said before, just checking to make sure that they're clear and legible. And then to follow, we can check to make sure that they're all in the right locations. Now we're going to be getting into checking the lockout valve or the stop valve. Now the significance of this valve in particular is it's essentially the last line of defense within the system prior to CO2 being discharged into whatever space it's required. At this point, we're essentially just checking general condition, checking for corrosion, but most importantly, we want to make sure that the valve is in a closed state as designed, so that when the system does get activated, CO2 isn't just immediately flowing into the space. And we want to check that the time delay bottle is properly rigged into it, so that personnel are allotted the proper amount of time to evacuate the space and that the system can operate as designed. And now we're going to be just checking to ensure that the system itself hasn't been discharged and that it is ready to operate if needed. In this case, there are more than one, I guess, way you can verify that it has not been discharged, but the best solid way to indicate is these actual pull stations. You're able to actually see that the pull station has been yanked out far enough that you'll see a little white indicating dot is usually the color coding to indicate that it's been pulled out far enough that the system would have been discharged. So again, we just want to make sure that everything's intact, the system hasn't been utilized by the time we're coming out to inspect it, and this is a good way to indicate that. Okay, so to briefly summarize the steps for inspecting the high pressure CO2 system. Today we've identified the hazards and cautions and PPE to be utilized when inspecting them. Verified the service and compliance report. We verified the presence and conditioning of the odorizing unit. We've inspected the stowage of the cylinders itself. We examined the material condition of the system components, the hoses, the bottle condition, the hydrostatic testing, and other servicing reports. We verified piping and nozzles are clear, heading to the spaces in which the CO2 will be discharged throughout the vessel. We verified the markings and warning signs are posted in the proper spaces, legible and easy to understand. We verified the operating instructions are posted and also legible and easy to understand. We verified the lockout or stop valve is in an approved state and in serviceable condition. And we verified the system discharge indicator does not indicate that the system's been discharged and that the system is ready to be used when called upon. Now, if there's any amplifying information you wish to seek or you have any questions remaining, feel free to reach out to your local VO and they'll be able to get those questions answered for you.